Design patterns provide reusable solutions to commonly occurring problems. MontiCore, of course, also uses various standard design patterns such as visitors, template hooks, factories and builders. Some of the heavily used design patterns have been substantially adapted or were even newly created. In this video I want to focus on 3 of those design patterns: the static delegator design pattern, the RealThis object composition pattern, and the template hook pattern. Static delegator design pattern. The static delegator design pattern combines the advantages of publicly accessible static methods with the possibility to redefine them. It introduces a hidden delegate object that can be replaced on demand for customization. Take a look at this code snippet of a static delegator method. The info method is the static method that is publicly available since it is meant for external use. Internally, it delegates the method call to its internally used object log, which in fact is an instance of the log class. The static method calls the instance method doInfo that provides the actual implementation. Static delegators may have many such pairs. The main benefit of this design pattern is that a certain set of methods is available uniquely through all pieces of code. This makes it still possible to redefine methods even though they have a static, externally visible interface. A drawback, however, is coming with the use of static methods. Web frameworks forbid those, and you might also run into problems when parallel processes need their own individual instantiations. RealThis object composition pattern. When generating code, it is convenient to generate independent artifacts that are tightly connected during runtime, especially when parts of classes originate from different generators. This class diagram shows how components use RealThis instead of this to enable a close collaboration. The main idea of this composition pattern is to compose objects that collaborate closely as if they were one single object. Therefore, an object holds an attribute called RealThis that references the this object instance by default. The original program execution stays viable. However, for customization, it is possible to change the getters and setters of RealThis to reference another object. In general, the RealThis pattern benefits from enabling late composition of functionality. The user will not even know that he works with a composed object. A drawback, however, is the overhead during implementation, because every occurrence of this has to be correctly replaced by RealThis. Template hook pattern. The template hook pattern is a very basic design pattern, but still, it is very useful for frameworks and even more so for the integration of handwritten and generated code while keeping both sorts of code separated. The simplest form of this pattern consists of 2 methods: the template method and the hook method. In the template, a predefined algorithm is stored that calls the hook to do some of the more primitive or more specific actions. In general, a hook point is a place within the template that is meant for adoption. A hook has a name, is defined in a template, and is filled by one or more hooks or values, while the defining template remains unchanged. A key mechanism in frameworks is to code the core functionality into the template that also belongs to the framework, and some basic actions to hook methods. The latter is meant to be defined by the individual application itself using subclassing of the respective framework classes. In case generated code should be partially extended by handwritten code, providing hooks leads to flexibly extensible generated code, meaning the generated code works similar to a framework. MontiCore uses the TOP mechanism to integrate handwritten code into generated code. Thus, most of the methods in a generated class work as hook points. MontiCore also applies the hook point mechanism to free marker templates.